In this video, I'm going to introduce compound interest. This section of your textbook, we're going to break into several different videos. Um, if you remember Math for Liberal Arts, if you took that course, this is similar to finding compound interest in that class. The problem is your textbook uses its own formula for it. That's not unusual. There's not one specific convention for writing the compound interest formula. They're all equivalent to each other. They're all logically equivalent, but different textbooks use different notations. They assign variables to different values, and that's kind of unfortunate because the book we use for Math for Liberal Arts um, does not match the book used for finite, just because they're written by different authors, even though at the moment they're the same publishing company. So this might be, you just have to stop and think about it, I think that will help. So first of all, let's look at what compound interest is. Compound interest is interest that's computed. In other words, we figure it out on the original principal as well as the interest that's already accumulated. Simple interest is just paid on the principal. Simple interest is just paid on the principal, and it's paid at the end, either at the end of the savings period or the end of the loan period. Compound interest is computed on the principal as you go. So interest can be compounded or paid either annually or semi-annually, which would be once a year or twice a year, quarterly, which would be 4 times a year, monthly, which would be 12 times a year, weekly, which is usually 52 times a year, but as I mentioned, I believe in the simple interest video, sometimes we say that for weeks it's really 50 weeks a year, even though it isn't. Just follow whatever the directions say. If the directions don't say that, then 52 weeks in a year, or daily. And we're going to say there are 365 days in a year unless the textbook or unless the problem says assume something else. And so as a really quick example, if I were to earn 4% interest on a savings account, that which is actually unfortunately be really good interest to earn right now. Good for borrowing, not good for saving. If I were to earn 4% interest on a savings account and my bank told me it's compounded quarterly, there are 4 quarters in a year, just like there are 4 quarters in a dollar or there are 4 quarters in a football game. That means my interest gets paid 4 times a year. I don't get paid 4% 4 times a year. That interest rate is divided by how many times a year I get paid. So after 3 months or 1 quarter, I get 1% interest earned on whatever I have deposited. And then after 6 months, I get another 1%. After 9 months, I get another 1%. And finally, after 12 months, I get another 1%. So I've earned 4% interest for the year, but it's been paid out quarterly. We call these compounding periods. So let's look just at a really simple example here. Let's say I deposited $100. That means, actually, let's say I deposited $1,000. That's actually going to be a little bit easier. After 3 months, my bank computes my interest, and my bank pays me 1% interest on $1,000. So after 3 months, my bank adds to my account 1% of 1,000, which is $10. So after 3 months, instead of $1,000 in the account, I have $1,010 in the account. So now another 3 months pass. Now I'm at the 6-month period since I first deposited my money. My bank pays me interest again. But now instead of 1% on $1,000, I'm getting 1% on $1,010. So I am going to get $10.10 interest. And so now I have $1,020.10 in the bank. After 9 months, my bank once more pays me 1% interest on this new amount. And so after 9 months, I'm going to get $10 and we're going to round to the nearest cent and 20 cents interest. So now I have $1,030. Whoops. Okay, we're going to fix this. And I'm recording this live because editing it is a huge pain. So you're going to see some errors, and I'm going to apologize right now. But part of what we want to teach in this class is how to deal with errors. So you're going to see my errors as I make them and how I deal with them. And so when I add these two together, I get $1,030.30. So again, this is my original value. After I get my first batch of interest, I have this. After I get my second batch of interest, I have this. Now after my third batch of interest, I have this. And then finally, at the end of the year, I get my last 1% interest payment. And so that's going to be $10.30. And so at the end of the year, I'll have $1,040.60 in the bank. If I had been paid 4% simple interest, at the end of the year, I would just have $1,040 in the bank. Now, you might think, and you'd be right, that 60 cents isn't a huge difference. And it's not a huge difference. The difference becomes more important the larger the amount of money is, and it becomes more important the longer the money is kept in the account. So if instead of $1,000 I had $10,000 in the account, then at the end of the year, instead of having $10,400, I would have $10,406. So again, not a huge difference, but still a difference. Luckily, we don't have to do all this addition. There is a formula to help us. It is the compound interest formula. It's the formula we're going to use throughout this class. This is the formula different books present differently, and this is going to look different than you probably learned in a previous math course, depending on where you took it and what the course was. So what you see here at the top is how your textbook defines the compound interest formula. They define it as, remember, A is future value, just like it is for simple interest, and P is principal or present value, just like it is for simple interest. What your textbook does differently is it uses the letter I. And when it says I, what it means is the interest rate divided by the number of compounding periods per year. So for the problem I just did on the previous page, I there would be 4% interest divided by 4 compounding periods a year, which would equal 0.01. And then N here is how many times altogether the interest is compounded. So for our purposes here, I just kept the money in for 1 year. So in this case, my N value is going to be 4 because it was compounded 4 times. If, though, I had kept it in some different amount of time, if I had kept it in for 5 years instead of 1 year, what do you think N would be if I kept it in for 5 years? So then N would be 4 times 5 for 20. So I want to make sure you understand this, and if you don't, please let me know. Please send me a question about it, or please ask a question about it at some point soon. If I just do it for a year, and it's compounded quarterly, that means N is 4. It's been compounded a total of 4 times. If it's for more than 1 year, I multiply how many times a year times how many years. So 4 times a year times 5 years, that would be 20. 4 times a year times 6 years, that would be 24. 4 times a year times 12 years, that would be 48. 4 times a year times 50 years, that would be 200. If it, instead of 4 times a year, it were twice a year, that's called semi-annually, Then I would multiply 2 times however many years it was in. So if it was just for 1 year, it would be 2 times 1. If it were 12 years, it would be 2 times 12. If it were 13 years, it would be 2 times 13. If it were 100 years, it would be 2 times 100. So what we do then is we just have this formula. So for what I just did on the previous page, it was this. It was my principal was $1,000 times 1 plus, and I figured that out up here, 0.01, and then I figured n here to the fourth. So that's going to be, I'm going to draw it down here, 1,000 times 1.01 to the fourth. I'm going to draw this so we separate this. Remember, we take exponents before we multiply. So what I would do on the calculator is first I would take 1.01 and I would raise that to the fourth power. And I'm going to try to do that now and probably have some issues trying to work on my thingamabobber here. Okay. So I'm going to pull up my calculator. So I'm pulling up my calculator. So first I take 1.01 to the fourth. So 1.01 to the fourth power. And then don't round. When you're using a calculator like this, as much as possible, don't round. If you have to write it down on paper for an intermediate step, write whatever the calculator gives you, all the digits you can. If you round incorrectly or you round too much in a middle step, your answer is going to be off. It's going to be inaccurate. So then I just hit here times, and that takes my answer times 1,000. We could really just by moving the decimal point. And we see that at the end of the year, I have $1,040.60, which is the same problem that we got, or the same answer that we got when we did it by hand 1 year at a time on the previous slide. So again, if you have the TI-84, which I strongly recommend for this course specifically, you can just do it like this also, because the TI-84 understands order of operations really well. I could in fact even do it like this. I could do it a couple steps back. And I'll get the same answer. That doesn't work on all calculators. If all you have is a scientific calculator, not a graphing calculator, then I strongly recommend that you play with the calculator to make sure it works right. All right, let's continue on then. Oops. Okay, I have to move some windows that you hopefully can't see. Not that they're bad, just because it's background stuff going on. There we go. So here's some important information. And I know there's a lot of text on this slide, and I try not to be text heavy when I design slides myself. This is an exception. I'm going to apologize. The top part is just what I've already said. Different textbooks use some different formulas. If there's a formula, if you remember a formula from another book, from another source, you want to use that, that's fine. You're going to get the right answer. All of these formulas are logically equivalent to each other. One thing that you definitely need to know are these values. So your textbook eventually is going to introduce the variable m. And m, as in math in your textbook, stands for how often interest is compounded in a year. Other textbooks use a different variable for this, and it's confusing because of that, I know. Your textbook uses m, and so does the work then in MyMathLab. This chart is something you need to know if you don't already. If you do already know this, I don't mean to insult you by saying that you don't, but I've learned that there are people who just don't who have forgotten this information. So if we say, or if a problem says interest is compounded annually, that means once a year. So M there would equal 1. If interest is compounded semi-annually, that means twice a year, M would equal 2. One that people often struggle with is quarterly, which is why I used it in my example a few minutes ago. Quarterly means 4 times a year. There are 4 quarters in a year, just like there are 4 quarters in a dollar. Monthly is 12. So if you see a problem that says interest is compounded monthly, you know that M will equal 12. Later on, you might just see a problem and it won't say that, but it will say something like you make monthly payments and there's compound interest. That's the same idea for our purposes in this course. If you make monthly payments on a loan, that means your interest is compounded monthly. Weekly. Weekly and daily are those cases where it's going to depend on the problem. Some books, including yours sometimes, uses the old-fashioned value that we're going to assume there are 50 weeks in a year. And again, that was used because we used to do all this by hand. And so if we're doing it all by hand, it's a lot easier to work with 50 than it is with 52 as dividing. By dividing something by 50 is quicker than dividing it by 52. So, but we're using a calculator. So unless the problem says otherwise, if it says weekly, we are going to say there are 52 weeks in a year, which is the correct number. But again, a problem might say assume there are 50 weeks in a year. And then it's the same thing for daily. Sometimes a problem is going to use the sort of old-fashioned notation that will assume there are 360 days in a year. But what we're going to do is we will, if it doesn't say that, use 365. We're going to ignore leap year. We're going to pretend leap year doesn't exist. And we'll say there are 365 days in any year. So don't worry about leap years. Like if you say it's over 10 years' time, you don't have to try to say, oh, there's 2 leap years in that time and stuff like that. We ignore that. So again, this chart is important. If you don't know this already, make sure you do know it. So let's look at some examples, and we're going to use the formula as your book describes it. So in each of these cases, I'm trying to find future value. I'm trying to find A. So our formula is A is the principal or the present value times 1 plus I to the n. And I is our interest rate divided by how many times a year the interest is compounded. R is interest rate, M is how many times a year interest is compounded. So I'm going to figure out these values, and I'm just going to actually plug these values in. So I want to know how much will I have in the account in the future? How much will I have? I'm finding future value. I'm finding A. So my future value A is my principal, that's what I've deposited, times 1 plus I. I is my interest rate, 0.04, and then compounded annually. If it's compounded annually, what will M be? If it's compounded annually, M will equal 1 because it's compounded once a year. So that's easy. 0.04 divided by 1 is just 0.04. And then N is the total number of times it's compounded. So it's the number of years times whatever M is. So here, 4 times 1. 4 times 1 is 4. Okay? So let's review this. I've deposited how much? $500. That's my P. That's my principal or my present value. I here is the interest rate divided by the number of times that interest is compounded. So my interest rate is 4%. I always write it as a decimal in an equation, of course, so that's going to be 0.04. It's compounded annually, so that's once a year, so it's 0.04 divided by 1. and then I'm keeping it in the bank for 4 years. So because it's compounded annually, that means it will have been compounded a total of 4 times. It's just compounded at the end of each year. So I can put this into my calculator now. All right, so I have my calculator on the screen. I'm just going to keep the calculator on the screen. I think it's going to be quicker. So I'm just going to plug this in again because I'm using a TI-84. I don't have to do anything ahead of time. It will handle all of this. So what I'm going to type in is exactly what you see after the equal sign. 500 parentheses 1 plus. I have a fraction here. A division problem is just a fraction. And I can just do this in my head, 0.04 divided by 1. But I'm actually going to do it like I normally would on this if it weren't divided by 1. And I'm just going to enter it as a fraction. And as I've said before, I like to enter fractions in parentheses. You don't always have to do that in the TI, but here it's going to be super helpful to do it this way, I think. And I think it just is in general. And then I'm going to raise that. I'm going to hit the exponent button. I'm going to raise it to the 4th power. So 500 times 1 plus 0.04 divided by 1 to the 4th power. And then I'm going to hit enter. And so I get, and we always are going to round this to the nearest cent. Unless sometimes the question will say round it to the nearest dollar, then do that. So rounded to the nearest cent, after 4 years, I will have $584.93 in my savings account. All right. So if you need to, pause the video, go over this, try to understand why I did what I did and all that good stuff. If you have questions about the problem, think about the questions, and then if you still have them, please send me an email and say, why did you do this or this or this? And I'll try my best to explain. Here's another problem, very similar. This one is, in fact, the only difference is that instead of being compounded monthly, my interest is compounded quarterly. So again, we have our formula. Future value equals principal, or present value, times 1 plus I to the n. And I is the interest rate divided by how many times it's compounded each year. So let's find the I right now. My interest rate itself is still 4%, just like it was in the previous problem. That's going to be 0.04. And it's compounded quarterly, so it's compounded 4 times a year. So now that I know what I is, I'm going to plug my values into my formula. My future value is going to be $500 times 1 plus 0.04 divided by 4. And now I have to figure out n. So I'm keeping it in the account for 4 years' time, and it's being compounded 4 times each of those years. So how many times will it be compounded all together? It'll be compounded 4 times 4. That's going to be compounded 16 times all together. 16 is 4 times 4. Okay? So now that I have this, I can plug this into my calculator. That's good. I actually need the whole calculator on screen to do that, though. So $500 times, and again, the TI-84 is smart enough to know that using a parentheses like this means times. Other calculators, like a basic scientific calculator, usually isn't. So you might have to put the multiplication sign in there. And you could do that on the TI too. It doesn't make any difference, but it's just a little quicker if you don't have to do it. So 500 times 1 plus 0.04, and then remember m here is 4 because it's quarterly. Make sure we always have matching parentheses. The same number of outside as inside. And then I'm going to raise that to the 16th. I hit enter. And notice, if my interest is compounded quarterly, I'm going to have more money in my account at the end of 4 years. The more often your interest is compounded in a savings account, the more money you're going to get, up until a certain limit. It doesn't get infinitely bigger. Even if you're compounding interest every second, there's still a limit that it doesn't go above. But we'll learn about that in the next lesson. So after 4 years time, I'm going to have in my account $586.29. So again, there's not a huge difference. If we look at the calculator screen up here, there's not a huge difference between compounded monthly and compounded quarterly. It's a difference of just under $2. So for a deposit of $500, that's not a lot. For a deposit of $5,000, I'm talking about almost a $20 difference. For $50,000, I'm talking about a $200 difference. Again, those aren't huge percentages when we talk about the amount, but it adds up. And so that's why if you're depositing money, you want the best interest rate you can find. And we'll talk more about that when we talk about how to find the effective interest rate, which we're going to talk about in a future presentation with this chapter. So again, if you need to, just pause the show, look at the slide, or pause the video, look at the slide. If you have questions, please let me know. We're going to do, I think, one more example. I deposit $2,050. I'm using some different values here to mix things up a little bit. I deposit $2,050 into a savings account. It earns 3.62% interest. It's compounded monthly. How much will I have in the account after 6 years? And so in all of these problems, we're assuming we're making an initial deposit and then we're just leaving the account alone. We aren't adding any more money to it. We aren't taking any money out. We're just leaving it alone. We're letting the interest accumulate. That way we earn interest on the interest. Later on, we'll talk about problems involving retirement accounts where we're going to have an initial deposit, or we're going to maybe not have an initial deposit, but we're going to make regular monthly deposits depending on how the problem's set up. That's a little trickier, but we can do it. So my formula again, future value is principal times 1 plus I to the n, and I is my interest rate, R, divided by M, how many times a year interest is compounded or paid. And again, this one on the top, that top letter is R. I know it looks a little bit off, but it really is an R, I promise you. So let's look at the problem. We'll do this first. Our interest rate, R, is 3.62%. So that's going to be 0.0362. And it's compounded monthly. So if it's compounded monthly, what will M be? M will be 12. So now I can plug my values in. My future value is my principal, $2,050, times 1 plus 0.0362 divided by 12. And now we'll figure out what N is. So it's 12 times a year for 6 years. So that's going to be 12 times 6 is what N is going to equal. 12 times a year for 6 years is 12 times 6, and 12 times 6 is 72. If you have a TI-84, you can actually put that multiplication problem in as your exponent. You don't have to multiply it out first if you don't want to, or if you don't know that by heart, which is okay if you don't. So let's plug this in, and I'll show you how the TI will multiply that for me. And again, a scientific calculator might not, but the TI will. It's one reason why a lot of math teachers like me like the TI. So 2,050 times the quantity 1 plus 0.0362 divided by 12, close parentheses, to the, and I'll just put in here 12 times 6. If you have a TI-83 instead of a TI-84 and your screen looks different than this, you might have to put the exponent part here in parentheses. Um, but but if you have a TI-84, you shouldn't have to if it's a newer one anyway. Or you could just always multiply it out first. So I'm going to have, after 6 years' time in my account, I'm going to have $2,546.48. All right. We spent a lot of time on this. The next video I'm going to put up after this one is going to look at these same problems again, except it's going to use your calculator and use an app on your TI-84 called the TVM Solver. The TI-84 isn't required for this course at ICCOC. It is required when this course is taken at Iowa Lakes in person rather than online. So this will also be applicable for you if you have to have a TI-84 for the follow-up video. If you don't have to have a TI-84 and you don't, there's no need to watch the follow-up video. If you have any questions, please let me know. I wish you good luck as you work on these concepts about compound interest.